Hello and welcome back, everybody. I hope you all learned a thing or two about observability, monitoring, the difference between it. Yes, no, maybe. I think so. If you probably didn't listen that much after lunch, it's perfectly fine. Our next speaker is going to elaborate on this topic a little bit more in a little bit more detail. He's a principal software engineer at Solo.io, coming from Hungary all the way. He told me his distinctive feature is that he's probably running the most over-engineered blog that's out there, especially when it comes to observability and to monitoring, so he definitely knows what's going on his side. His name is Krisztian Fekete. Please give me a hand for one of the best engineers at Solo.io.
Hello, everyone. Thank you for joining me for this call, and thank you for the organizers for having me. So, the title of this talk is Should I use Otel collectors or is Prometheus good enough? And in this session, we will try to answer this question. The organizers said that I only have 25 minutes, so this is the shorter version. But we will take a look at various use cases and see when it makes sense to use Otel collectors and when and which situations there are better tools for the actual job. My name is Krisztian Fekete. I work at Solo.io. These are my contact informations. If you want to chat about anything that I covered or didn't cover, feel free to drop me an email or reach out on these platforms, and I'm more than happy to chat about things. This is lots of words on my background. I only included all of these so that I can show that I have experience not just with OpenTelemetry. It won't be an OpenTelemetry pitch. Some days I like OpenTelemetry, but not each and every one of the days. I have also used Prometheus pretty extensively at my previous jobs. And there are trade-offs everywhere. I work at Solo.io. We are one of the main contributors to Istio. Who is maybe already familiar with Solo.io? If I can say, okay, a couple of people, not yeah. It's a quite good ratio. And who is using Istio? Okay, there are some hands, but the two groups are doesn't necessarily have that many people share between them. All right, so we are an application networking company. We are using those open source technologies that you can see on the bottom. We are using those as a foundation, and we are trying to make all these production ready and enterprise ready, and helping our customers to modernize their application networking stack and to help them to run microservices in Kubernetes clusters. This is the agenda for this talk. First, we will take a look at OpenTelemetry, and I will try to clear up some confusion about the different OpenTelemetries that are out there, because if you have looked into OpenTelemetry or try to do something with OpenTelemetry and you talk with someone else, then you might have the feeling that, okay, there are multiple OpenTelemetries out there. Does this resonate with anyone? Or no, not necessarily. I will show you at the beginning of the session what I'm talking about. Maybe after that it will be more familiar. But yeah, I will try to make it simpler to signal which OpenTelemetry are you talking about when you are talking about Otel. Then we will take a look at the state of the world before OpenTelemetry and after OpenTelemetry. What is the promise? How can it help? Then we will take a look at 3 different case studies and see what kind of trade-offs are there and what kind of questions the people working on those platforms and in those circumstances should take into consideration before making architectural decisions. And yeah, that will be the talk. After that, I will try to summarize everything. So first, OpenTelemetry. OpenTelemetry is becoming more and more popular. You can see the Google Trends graph about its popularity. You can see that how it's growing over time. But if you scroll down on Google Trends, then you can also see additional information on how people are searching for OpenTelemetry. I already presented this talk a couple of times, and the first time it was almost a year ago, in 2023 October, and you can see how the search terms, the related queries, are different today than it was last year. You can see that people are arriving to or searching for OpenTelemetry in many different ways. OpenTelemetry collector is still the most popular, but there's OpenTelemetry Java, Jaeger OpenTelemetry, Jaeger. If we take a look at the left side, on the right side we have Prometheus, OpenTelemetry Metrics. So there are lots of ways to search for OpenTelemetry or use OpenTelemetry. If you take a look at OpenTelemetry.io, then this is the simplified definition that we can see on that website. It's a collection of APIs, SDKs, and tools. That's very concrete. Use it to instrument, generate, collect, and export telemetry data, metrics, logs, and traces to help you analyze asset performance and behavior. After this is already a simplified version and not the original version that I included in the first edition of this talk 1 year ago. They moved most of the confusing part into another section on the website. If we scroll down, this is what we can see. An observability framework and toolkit designed to create and manage telemetry data, traces, metrics, logs, vendor and tool agnostic, meaning that it can be used with a broad variety of observability backends. So there are multiple backends, including open source tools and commercial offerings. But at the same time, it's not an observability backend like Jaeger, Prometheus. So this is where it can be hard to understand everything and making clear which part of the OpenTelemetry ecosystem you are talking about. To be fair, if someone wants to include everything or that many things from the observability landscape as OpenTelemetry, then it will be very challenging to come up with a very simple definition. People will be confused because there are lots of tools in the ecosystem, and it's easy to get lost in all these different tools with the same name. So this is my attempt to try to simplify that. So if you take a look at the original definition, then we see that OpenTelemetry is a collection of APIs and SDKs. So you can use the former ones, the APIs and the SDKs, to instrument your application, to emit telemetry signals, observability data, basically. Then you can use the later ones, the tools, which is not very clear. It's a bit vague, but I will go into more details quite soon. The later ones, the tools, to collect, transform, and ship observability data. And the last confusing part is that might or might not be originating from Otel instrumentation. So to simplify it, APIs and SDKs are at the instrumentation layer. When you are adding telemetry into your applications, when you are instrumenting your applications, you are using those. Those are also called OpenTelemetry. And also there are tools like OpenTelemetry collector and operator, and you can use those to collect, transform, and collect these telemetry signals. And that's the tricky part, that it might or might not be originating from Otel instrumentation. I will talk about that in a few seconds. So this is the diagram that I created. There are the libraries, SDKs, there are the collector and the operator. So the operator and collector are the tools from the previous slide. These are not the same thing, but both of them are called Otel or OpenTelemetry. So for example, if you're talking with someone with an ops background, they most probably mean OpenTelemetry collector and the operator. If you're talking with someone who is actually working on instrumenting services, then they are most probably referring to the libraries and SDKs. And the last part, where most of the confusion is coming from, I think, is that you don't necessarily need to use the OpenTelemetry libraries to expose and emit telemetry data, and that's the case even if you want to use if you want to use an OpenTelemetry compatible backend at the very end. So you can use either OpenTelemetry instrumentation or any kind of other instrumentation. For example, if it's a Go application, you can use Prometheus client Golang, expose your metrics, and you can still use an OpenTelemetry collector to collect all this information and ship that to any Otel compatible backend or even Prometheus just very recently. So I think these two slides are aiming to simplify what are the differences and what's the overlap between all the OpenTelemetries out there. The collector itself, which I will be mainly talking about, has an architecture that is that you can see on the slide. You have the workload applications on the very left, and on the very right, you have the destination where you want to push your observability data. In the middle, you have the actual collector that has a couple of stages. So first, there's the receiver, that is basically the config. That is the component that is collecting the data. You can either scrape data or poll data or push to the collector. Then there's the processing layer in the middle. You can enrich the telemetry data that you have. You can get rid of high cardinality metrics, for example. You can drop some information that you don't need. You can mask some information if you don't want to ingest those into your actual backend. You have lots of options there. And then at the very end, you have the exporters, and those are just basically responsible for providing an interface so that you can push all the data into any kind of backend. That can be a commercial offering, or that can be also an open source tool. So let's take a look at the state of the world before OpenTelemetry collectors. That might be still a case that if you are running a mostly open source observability stack, you are using tools like this, Prometheus, FluentD, FluentBit, or Jaeger. You can use many other, for example, Grafana, Labs Tempo, or you can use another log shipper agent. There are many different ways to do the same things. But these were tools that were good for one single purpose, and it was fine. You could use them to explore logs, metrics, and traces. On the other side, if you have lots of money, you can use commercial solutions as well. Dynatrace, Splunk, Datadog, New Relic, lots of other vendors. There's a new observability vendor coming up every quarter or every year almost. These vendors usually have their own agent, and you are using that agent to collect logs, traces, and metrics and ship those to the actual platform that's the owner of the agent that you are running. The problem with this agent is that it's quite tedious to configure. You cannot easily, you have vendor lock-in. You actually have vendor lock-in. You cannot easily migrate from, I don't know, New Relic to Dynatrace or another solution because they have a different agent, they have a different configuration language, they are also ingesting data differently. The data that you are collecting and shipping to the backend will look differently if you are using another agent to push that information. So this is where OpenTelemetry can help because it should be providing a standardized way to collect, enrich, transform, and ship observability data to any kind of backend. So this is the promise of OpenTelemetry. This is the same diagram that I had on the screen before. You can see that in this case we have a Prometheus receiver. That's an almost drop-in replacement for a Prometheus server. It's not a storage. You cannot. It doesn't have the TSDB. You cannot run queries on them. It cannot help you with alerting, but it can scrape targets on your system, and you have the metrics collected in the collector. Then you can do some processing in the processing layer and push that to Datadog, for example. So this is basically a simplified replacement for a Datadog agent, let's say. But let's imagine that you also want to collect logs. In that case, you can add a new receiver. You can also push, but in this case, file log receiver is basically reading the log files from the disk, and you can get the logs in this way. You can do some processing again, then ship those to Datadog. So you can already see that the benefit is that you don't need to use. You can use the same component. Using the same component doesn't always make sense. You can also use dedicated collectors for dedicated telemetry signals. For example, I would personally recommend using a dedicated collector for tracing, another one for metrics, because you don't necessarily want your I don't know, tracing pipeline to affect your metrics pipeline, because you are most probably doing alerting based on metrics. So that's a critical one. While tracing is also useful, that's easier to overload, and metrics at the end of the day, in most cases, are still the de facto ways to at least fire alerts, for example. So you have the option to separate these. But the actual component, the query, the config language, everything is fairly the same. And if you decide to use another backend, not Datadog, but switch to another vendor, you can easily do that without rewriting your whole stack. You can see a third variation of this diagram on the screen there. In this case, we have a new OTLP receiver. That's where you are pushing to the actual collector. You can do the processing just like before. And then you can also add multiple exporters. So in this case, I have Loki and OTLP. Now also Loki is using OTLP. Loki exporter, I think, is already decommissioned. But the thing is that you can use dedicated exporters for different purposes. You can use another one for your production system. You might want to use a commercial vendor for production, but you don't necessarily want to do that for your dev or staging environment. So you have the flexibility and option to do so. So let's take a look at the different scenarios and see what are the trade-offs and what are the questions that I think everyone should discuss with the team responsible for making these changes before making these changes. And we are mostly focusing on metrics, unless I say otherwise. So this is scenario 1. I'm a cloud architect working on my company's infrastructure. We are managing hundreds of Prometheus instances across multiple on-premise data centers and Kubernetes clusters. Should we get rid of all of them and switch to Otel collectors? This is an actual question that I heard multiple times, because there are some cloud architects or architects out there who have ideas like this, because OpenTelemetry is becoming more and more popular, and there's the Prometheus receiver that I mentioned. So it might seem like a good idea to do this. But people might not want to do that right away. So I propose a couple of questions to discuss that, because I don't know, some people might not be even aware of that. Okay, how can I use an OpenTelemetry collector to replace Prometheus instances? Technically, it's possible. So this is the Prometheus receiver from the OpenTelemetry collector contrib GitHub repository. This is the receiver that I mentioned earlier. You can scrape targets on Kubernetes clusters with that easily. But you can see that there are some warnings and unsupported features, like, for example, alerting. You cannot store rule files. After this, the collector will become a stateful component, so you need to take the different failure modes into consideration. Auto-scaling is also trickier, because you either are using a daemon set and you are in a more fortunate situation, or you are using a daemon set, but if you are using a daemon set, it's not trivial to scale out horizontally your collector, because if you have multiple one of those running on the same node, then you are scraping targets multiple times. All of those are ingested by the collector, and you are getting out of order error messages. So these are the questions that I propose discussing with the team. The first one is there any problem with the current solution? Because if not, then probably the current architecture is fine as is. But let's say it's reasonable to do this change. In that case, the next question I recommend to discuss is the failure modes. What are the failure modes of the original system, and how these will change with the new model? What happens if your Prometheus instance dies? What happens if a collector dies? How you can scale those out? What happens if you lose some replicas but not all of them? What kind of data you have at one of your collectors? What happens if you have impaired connectivity between your Prometheus and your centralized system? What happens if you have the same problem between a collector and your centralized system? Let's say your centralized system becomes unavailable. As I mentioned, with an OpenTelemetry collector, you cannot run queries on it. So while when you have a Prometheus that is either with a sidecar or a remote write integration writing into Thanos, let's say, and that's the long-term storage. If your Thanos becomes unavailable, or at least the connectivity between the two clusters, you still have the local query capabilities and alerting capabilities from the local Prometheus. If you have a collector, you don't have these capabilities, and this is something to be aware of. Then you can also try to come up with a probability percentage for all of these various scenarios and collect all of them and discuss with your team which scenario your team should be preparing for the most. Then there are some other questions to discuss, like for example, resource usage. You can also use Prometheus agent mode, which is fairly similar than an OpenTelemetry collector that is just collecting metrics. And for example, with remote write, writing everything into Thanos or any kind of remote write compatible backend. Prometheus agent mode can do the same. That's also lacking the query capabilities. So it might make sense to compare, for example, the resource usage of Prometheus agent mode and OpenTelemetry collector, because there will be some difference. Prometheus agent mode is much more performant and lightweight than the collector itself. Then, as I mentioned, another question is the single point of failure factor in the new architecture. I don't think anyone should use a shared collector in a production setting that has, I don't know, an extensive tracing pipeline and also shipping the metrics, all the metrics from all the workloads. It's better to separate these and run at least multiple versions of multiple deployments of the collectors so that you can handle all these signals separately. There's also a different scaling strategy for example, for daemon set and deployment. So these are all questions to take into considerations. So in this case, I would say that's a maybe. If you are well prepared and if you went through all these questions and maybe all the other ones that I probably missed, it might be a good idea to do that, but you should be aware of the actual trade-offs. Scenario 2. I'm an SRE working on a SaaS infrastructure. We are running one or multiple proprietary usability agents, and my observability vendor is a core contributor to OpenTelemetry. Should I switch to Otel collectors? Again, it's not a simple question. These are the proposed questions to discuss. What kind of telemetry data you are collecting? Is it only metrics, or are you collecting all the different signals that is possible? Again, single point of failure factor. Do you want to use a shared one? Are you currently using a shared agent to do all of this? Or are you considering splitting this into dedicated components? Next question, what is your observability strategy? Are you considering migrating away from your current vendor? Or are you just want to be prepared for the situation when, I don't know, someone acquires your observability vendor and you might not want to work with that other bigger company because they might, I don't know, change pricing or switch to a different model that might not make sense for your company. Apart from this, you should always consult with the vendor's limitations page, because OpenTelemetry is very easy. You have an exporter, you configure the OTLP endpoint of the vendor. Maybe you also need to, most probably you also need to provide your API key, and after that you are pushing all the data into the vendor. But without taking a look at the limitations, you might be up for a surprise, because that data might be considered custom, and the vendor might be charging an extra for everything that is coming from an integration outside of their agent. Or the data might not look that good as it looked when it was originating from their agent. So these are all scenarios that you should probably discuss with the vendor. What's the cost? Cost is, again, can be different, especially if it falls into this custom metrics, custom logs, custom telemetry category that I just mentioned. And it's always good to have a migration plan. A phased approach always makes sense. Yeah, just make sure that everything is compatible with the previous architecture. I would say this is approved if you are on the lookout to migrate away or to have the option to avoid vendor lock-in. I would recommend to do this, but again, make sure that you are following these questions at least so that you are preparing for the limitations. And this is the last scenario, and I'm almost running out of time, so I will try to speed it up. Last scenario, you are a vendor delivering an observability solution, but you are not an observability vendor, but you have some observability capabilities. How should I make my telemetry pipeline scalable, both in terms of ingestion, processing, and integration? And this is basically our story, because this is the architecture that we started out with. We have a multi-cluster setup, naturally, where we have a management cluster and we have workload cluster. Workload cluster is where your business applications are running, and we had an agent there, and the agent had communication with the management server. And originally, our agent was pushing all the metrics that it collected from the workload metrics and was pushing them up to the management server. Unfortunately, that agent had other responsibilities as well, so we had lots of issues with this integration. It was not scalable. We couldn't have a way to filter the metrics, add anything else than metrics. The agent was already overloaded with other tasks. We couldn't really integrate with any observability vendors, so it was a challenge to go with that architecture. In the new architecture, we have OpenTelemetry collectors. So it's basically the same, but if you take a look at the workload cluster, you see that we have a glue telemetry collector that is collecting logs, metrics, and traces, and pushing them up to the management server where we have a glue telemetry gateway. That's, again, a collector, but it's deployed as a gateway, so it has an OTLP endpoint, and it can receive all the data that we are pushing in. The good thing about this is that we can have a fine-grained pipeline between the collector and the management server, so we can make sure that we only send the data that is needed for our UI to work. And at the same time, as I already showed you, there are lots of various exporters, and the ecosystem of OpenTelemetry is the best in terms of ecosystem and integration. So we can easily push the data, all the data, not just the one that we are collecting in our pipeline between our collectors, but you can easily push all the data, even the one that we are not making sense of, to your observability vendor. In this case, I would say it's a good approach. If you are a vendor and observability is not your key focus area, it's not your differentiator, then it doesn't make sense to reinvent the wheel, ship your own agent, and do everything, because OpenTelemetry is already available. The ecosystem is unbeatable. You can integrate with anything, basically, and push the data there. We don't want to provide an observability solution ourselves for our customers, but we want to make them successful, and we want to make sure that they can push all this data into the vendor of their choice. So, takeaways. I hope the first couple of slides can help you to understand the differences in all the OpenTelemetries and make it easier to understand to the other parties which OpenTelemetry you are talking about. Next one is OpenTelemetry, not a silver bullet. There are trade-offs. There are trade-offs everywhere, and our job is to find them and advocate for all of these trade-offs and choose the optimal solution for the problem at hand. And the last one, don't reinvent the wheel. If there's something that is very popular and everyone is using that, then you should also probably use that and contribute to the ecosystem to make everyone's life easier. These are some references. The slides will be available, so you will be able to take a look at these. You can also join our Slack channel, slack.solo.io. And yeah, I don't think I necessarily have time for questions, but I'm available right after the talk, so feel free to come and ask those if you have anything related to this or application networking. Thank you.